So in this video we're going to do live refactoring of the code, making it work and talking through the thought processes so you see where I get it all confused. So let's get started. So I'm going to create here. Okay, so let's just do Google search. And let's instantiate this. So let's create this, create class. Let's automate Google search. We don't want it in test, we want it in main because this is part of our abstraction layers. Call it site domain. Create this as a field. Okay. So now we've got Google search. So this search page should really say google.search for, and then the search term and the match in URL. Now, Google doesn't have a search for, and search for is going to have this, and this needs WebDriver. So what we're going to do is I'm going to, now normally I like to refactor so that everything works in small chunks. So I'm going to do a quick, slightly different abstraction approach to this. So this is ideally what I want, but I'm going to start by injecting WebDriver into here so that I can continue to use it in other places. So I'm going to say Google search driver and the URL. Let's add WebDriver in. Let's go off to Google search. Let's keep the driver. There we go. So now Google search for. So when I do Google search, it's going to actually do a driver.get on that. So every time I instantiate a new Google search, it's going to do this. Now, people don't like having things like this in the constructor. Tough. That's what we're going to do to start this thing moving. So now I can say Google search for. Now, to start with, I'm just going to move this code into there. Now, I think this should probably be a separate object, but for the moment, that's the only step I need to do. So I'm basically saying Google search for, and it should do that. We've still got driver here, so the rest of the code should still be able to use driver. What we don't have is a wait, so let's create a wait which is local to our results checking. So that's actually slightly better for us because the initial search might need a different wait time than our div waits. So let's make this 3 here. So our code should still run, but we should now have the start of our search abstraction. Let's see if this works. So I'm going to change this back to one that we know matches so it doesn't keep going all the time. Let's run this. Wow. So either I'm really not in the search, I'm really not showing up in the search, which is unexpected, or I've done something wrong. Seriously? My site is not in this? Wow. Okay, so that's really bad. Yesterday I was on page 2. Now I'm nowhere. But this morning I was on page 2. Oh, so this is interesting. So in google.com I don't rank. On google.co.uk I'm on page 2. Okay, so I'm learning about Google and search engine optimization, and I assumed that results in google.co.uk were the same in google.com, but they're not. So this tool might actually help me investigate that if I can get this working properly. So there's an idea for a tool there, so that's interesting. So I'm going to change this search to something that I should rank for. I'm just going to make a note. So feel free to repeat these searches and see whether I'm going mental or not here. So this should just get to page 1. Right. So that doesn't even change the page on that because we find it in page 1. So that's fine. Okay. So that's a business issue I have to deal with. It's not an abstraction issue. So we've got a Google abstraction for search. Now, the next thing is to have this results checking abstraction. So what I was thinking is, instead of having a while loop, have a do while loop. Because we do a search, then there are results, then we process them, then we click next. So I'm going to say, while we have not found a match, and we have more results. I don't want that in the while, I want that in a do. So I'm going to say do this stuff while we have not found a match and we have more results. Which means I have to set have more results in here. Now in theory, for this code, I don't really need to have more results, because have more results is if we can click it, then we had more results. If we try and click it and we can't click it, then have more results should be false. So what I could do is put this in a try catch exception. So try this, then catch, and it should be a, well, let's just catch a generic exception and say have more results equals false. So this is really if found match, then report this, otherwise no match. So let's see if that works. So there should be no exception now when this runs and it doesn't match. So I'm going to go back to Prolog programmer because that's much less embarrassing. So I don't expect to match for Prolog programmer. I do expect to match for Selenium training. So I need to work on that. So I'll probably speed this up in the video because otherwise we'll sit here for about 40 seconds. But I will sit here for 40 seconds, a minute, however long this takes to run. So we got to the end of the search results and it found no match. So that loop's working. So let's just make sure that it works for a search. So what I tend to do, the reason I'm doing this, by the way, is I like to make changes in the code, then refactor when I know they're working. Right? I don't want to refactor and make changes all at the same time. And this change of doing the loop is important for me building the refactoring because it will let me change the refactoring to fit in more with the plan that I had. So the checking for whether it's got more. I can now do that. Basically now we're saying, does it have more? Yes or no. And then we can have a simple do while loop. Whereas I couldn't really do that with the loop structure that was in there before. So let me check that the previous approach still worked. There we go. So both conditions seem to still be working. It's saying we found a match on page 1 and we didn't find a match in the other one. So now we can refactor this. So the plan is we're going to refactor to has more, get more, and scrape results. So let's start with a google.results.scrape results thing, because we can do that in here. Okay, so let's do this. google.results.scrape. So google.results.scrape. So this is going to return, this results is going to return a new abstraction there, which is going to be Google search results, which I will instantiate with the driver. Okay, so then we need to implement the scrape mechanism. The scrape mechanism is going to be very like this, but instead of returning the result entries directly, it's going to do this. It's going to return the result entries, it's going to loop over them, and it's going to construct the list of domain objects that we want. So I'm just going to copy this for the moment. So we don't want any of this matching stuff, because that's going to still be done in the test. What I do want is I want to create a list of titled URLs. So let's bring in the class for that. Let's create this. I'm just going to leave it like that for the moment. In here, I get the href, I get the title. What I'm going to do is I'm going to say titled URL equals new titled URL for this href, for this title. Let's create that constructor. Now, in theory, I should probably have accessors for href and title. But to start with, because I'm creating them in the constructor and I'm making them final, I'm just going to make this public. So I can hear all the boos and hisses from the audience. Now, tough. This is how it works. So I've created a titled URL in this scrape loop. What I want to do is add it to my list. I won't print these out here. In fact, I will just print these out here. In fact, no, I won't. I won't print these out here. What are you doing, Alan? Okay, I won't print these out here. And then we'll return the results URLs. So you can tell I've planned this way in advance with what I'm going to do here. So there we go, result scrape comes back. So now this says scrape. So what we've got is a list of titled URLs. So I don't need this anymore. So I don't have this. So what I've got is a list of titled URLs. And what I will print out is the test is still doing a lot of work, but this scraper is just doing scraping, returning URLs. The matching is still done here in the test. We've still got the synchronization here, but this should be, if this is working, this should be good enough to start with. So that's the first refactoring part. Let's see if that's still working. So when I run this test, I'm expecting to see no difference because I'm refactoring, or supposed refactoring. Kind of changing code as I go, so it's not strictly refactoring, and there are no unit tests, so it's not refactoring. But what I'm doing is building abstraction layers. Whether these are the right ones or not kind of doesn't matter. What I'm trying to do is move things that logically should not be in here somewhere else. And then once they are somewhere else, presumably if the abstraction layers in here are at a nice enough level, I can amend what is going on under the covers. But my aim is to get rid of things like this in the test, right? Because I don't really care about the implementation of how this Google search is being done. I want everything kind of in context of this, and eventually move to this. We've got this synchronization. So this is basically saying wait until the results are ready. So let's do that. So this is slightly different from what I had planned. So let's say google.results dot wait until available. If I create that, then what I'm pretty much going to do then is just copy that in there, or move that in there. So this doesn't have a wait. So I could create the wait in here, but I'm going to do that up here. Oops, I want that to be a field. Google do a search. Google results, wait until they're available, then scrape them, get them, then this will be get the next results. So really I should run this first, make sure it works. Let me try that for the embarrassing search. Woohoo! It's on page 16. It's a bit different from page 2. Okay. Right, where are we at now? So this stuff. This is going to get refactored out into the Google results. So what shall I say this time? Google.results. Get next. Or get more results. And this can return true or false for have more results. If it manages to get more, then it has more results. Does that make sense? Let's do it that way. And all of this will be going into that get more results. Let's set it to false to start with. You can take issues with my coding style or whatever else, but that is easy to change. What is important here is this external interface good enough? That's where we should focus our attention. The internals we can refactor and change however we want. What's harder is once we've actually got it in an abstraction there, when we do refactoring the external interface, it impacts the stuff that uses it. So this has to be good enough to support what's going on. And at the moment, it's a very crude set of abstractions because I'm just modeling the one usage that I have. And that makes sense. So I'm building an abstraction there to support what I'm doing. It may not support what I want to do in the future, but then I have to figure that out and refactor it and possibly split it into other abstraction layers when I do that. But now, having done that, I don't need this wait anymore. So that's given a value in here. And I've still got drivers being instantiated here. So what should I do about that? What I should do then is say, I'm gonna say google.endSearch. Now because driver isn't instantiated here, that's a little bit dangerous. So let's not instantiate the driver in the constructor. Let's take the driver out entirely. So this is a little bit better in the sense that it doesn't have any of the WebDriver implementation. So we don't actually know how this Google search stuff is working. We just know we have a Google search thing that uses Google search. So in theory, I could swap this over in the future to the proper Google search API and leave my test here, leave my tool untouched, if I can use their API to model this approach. And then probably scrape should be refactored to mean get results rather than scrape or return results. In fact, we should do that now. So scrape is very much the implementation of a web scraper. So we're going to say refactor that to return URLs. So it's a little bit less we are automating the front end terminology. Now all of this is a Google PageRank checker, and Google PageRank checker could delegate through to Google search. So I could create this now, and then this code is pretty much what would be in check rank. So this is the check rank process. Then instead of system.outing the message, I construct a PageRank result object. But I'm going to make that just a to-do. So essentially, we have a abstraction that meets my plan. We have no WebDriver implementation in here. We instantiate the search terms. The logic of what this test is doing or what this tool is doing is in the tool level, not in the abstraction level. The abstractions use WebDriver, but don't expose WebDriver. They don't use page objects because it's only been used in one place and it's using the results rather than exposing them to be manipulated at a lower level of detail. And it's all ready to be reused and refactored in more detail. So I'm going to check this in. Since this video's gone on a lot longer than I expected, I'm going to stop there. For a quick retrospective, what we can see is we have refactored it. We have created an abstraction layer, and it's at this search level. It doesn't expose the implementation details, which is good because this is not really how we want to implement a Google search. We want to use their API, or I could possibly use a different technology instead of WebDriver. I could possibly use an HTTP library directly, although with Google I'm not sure how that's going to work because I think there's a lot of AJAX calls. You saw one of the reasons why this type of automating approach is a bad idea, because Google saw that we were doing strange things to its search engine on my IP address and then kind of said, no, you're only going to get to do this if you work within the confines of our CAPTCHA. So to bypass that, I've gone through a VPN so I get a different IP address. But that wouldn't have happened if I was using their API directly. Really, I should have instantly been using their latest API, which is the Google Custom Search, which means I have to set up an API key, use their API, do it that way. So maybe in a future video, I'll do this and show you the proper way to automate Google search. Also, this isn't a test abstraction. This is a usage abstraction. A test abstraction would support the level of testing I want to do. This lets me test results. This lets me test, can I do a search and are these particular values in the results? That's the level that is returned and I can manipulate in the abstraction there. It doesn't let me check does the Google search page render the input field in the right place? Does it let me click the button? Is the button disabled when there is no value in the text field? Is the button disabled when the text field contains invalid characters? That kind of thing. I can't test that with this abstraction. I would need a different abstraction for that. I'd need a page level abstraction because that's the level that I'm testing. And the reason for going through the part of this process, and I really want to stress this point, is different abstractions support different use cases. This abstraction supports usage. Test abstractions support testing, asserting at low levels. Some of the test code that we write is essentially a scenario and is essentially a use case until we get to the point where we're on a specific page where we test it. Like this abstraction might be useful if I was testing Google, because I just want to do a search, then click through a couple of times, then on that page I want to go down to a lower level abstraction and actually start testing the page, make sure the cached menus appear, etc, etc. But I would just use the system until I got to that point, which is why having multiple layered abstraction layers can really help with our testing, can make our tests more readable and let us drop down to do the work we're doing. So this is an example of approaching abstraction, even though it took a little bit longer, even though we encountered issues, and the decisions and thought processes we make. So I have a fairly clean test. I also have abstraction layers that I can amend. I can push this into page objects if that becomes appropriate. It's less appropriate at the moment, so I can kind of just leave this. I don't like this end search because it should probably just happen automatically, but I'm needing to do that at the moment because we've got this underlying Google search here, and Java doesn't really have a deconstructor. So I could add code in the finalizer, but I don't know when that would be called, so the browsers might hang around for a bit. So I'm making this much more explicit, which is fine, but it's not really required for my search abstraction. It's required because of the implementation that the search abstraction uses. So I hope that all made sense. You can see the code on GitHub. So subscribe to the channel and be notified when we release more videos like this or any other testing videos on EvilTester videos.